Okay, so we are starting a new unit, and in this unit we are going to learn to name compounds as well as writing chemical formulas for compounds. In this video we are going to focus on naming ionic compounds. Okay, so to start we need to review something that you should have learned in middle school, and that is, what is an ion anyway? So an ion is an atom or group of atoms with a net positive or negative charge. Okay, so we know that protons have a positive charge and that electrons have a negative charge. Okay, usually, and what we've talked about so far this year, your number of protons is equal to your number of electrons. And because of that, you have a neutral atom. You have a neutrally charged atom. It has no charge. Okay? However, sometimes we gain electrons or we lose electrons. And when that happens, our charge of our atom changes. So if we end up gaining electrons or gaining negative charges, now we have a negative ion. Or if we lose electrons, then we have a positive ion. Okay, cations are positive. Okay, so one way I like to kind of try to think of that, and yes, I do have my pen back. Yay! All right, is cations are positive. Okay, so they're positively charged ions. Sodium is an example, and we represent it with its positive charge. It's got a positive charge of 1. And anions are negative. I can't draw anything cute there, but they are negative. Okay, and an example would be chloride ion. So these are just from my periodic table. Okay, one thing to note, cations. Cations are going to be your metals. Okay, and they are going to have lost electrons. Okay, anions are going to be your nonmetals. And they are going to gain electrons. Okay, so just look here on this periodic table. You have this little zigzag line going on right here. Along that zigzag line, you have your metalloids. To the right of it, you have your nonmetals, which are going to form your anions, and to the left, you have your metals, which are going to form your cations. Okay, sweet. What are polyatomic ions? Poly means many, so that must mean many atoms, okay? So basically, they're just ions that contain more than one atom. So I'm just going to give just a quick couple of examples. If it's got more than one atom, like an oxygen atom and a hydrogen atom, that's called hydroxide. You're going to be given a list of these anytime that you take a test. It's on your STAR reference materials that you have. So it'll always be provided for you. Usually your polyatomics are going to be anions. They aren't always anions, but most of the time they are going to be anions. The one exception I can think of is ammonium, which is a cation. It has a positive charge. Okay? See how much more beautiful that is when I have my pen? It's greatness. Alright. What are ionic compounds? Ionic compounds are made up of cations and anions. So I combine a positively charged ion and a negatively charged anion. So in an ionic compound, for it to be electrically neutral, because our compounds need to be neutral. Okay? So I'm going to take a positively charged thing and a negatively charged thing, and I'm going to put them together. However, sometimes things don't have the same charges, but the sum of their charges of the cation and the anion in each formula unit must be 0. So I must have a certain number of cations and a certain number of anions to make sure that they balance out and that my compound has a neutral charge. Okay? Because of this, we need subscripts. So when I'm talking about a subscript, so y'all all know what the chemical formula for water. I know this is not an ionic compound, and yes, I know that. Alright, but you see this little 2 down there? That little guy's a subscript. Okay, we call that little guy right there a subscript. Okay, naming binary ionic compounds. So binary means 2. So if it has 2, just one anion and cation, just 2 atoms, we're going to learn how to name them. Basically, You name the cation, you name the anion. Okay? So first you're going to name the metal or the cation. Second, you're going to take that anion and you're going to take its name. Okay? You're going to take the first part of the element's name and add IDE or "ide" to the end. Okay? So I have an example down here and you would be expected to be able to name that. Okay? To write a name for that. And I'm going to look at my periodic table and I'm going to find Na and I find that it's sodium. So I name my metal cation first. So I just write sodium. Okay, so that's the first thing that I do. The second thing that I do is I'm going to take my anion, and this is a chlorine. This is a chlorine atom. Okay, it's a chlorine atom. But as an ion, because it's my anion, I'm going to change it from chlorine to chloride. I'm adding an IDE to the end. So I have sodium chloride. Why in the world I would have put a 4 there, I have no idea. That's the second thing you do. Alright, where in the world did I get a 4? Anyway, Mr. Neiman is losing it. Okay, more naming examples. I just wanted to throw out a couple more for you. K, I find that on my periodic table, it's potassium. I find Br on my periodic table, it's bromine, and so it's potassium bromide. Okay, this is zinc. Okay, this is zinc iodide. This is aluminum oxide. Okay, so those are just some examples for when you're naming a binary ionic compound. What about naming with transition metals? So transition metals on my lovely periodic table behind me are from the elements from groups or the columns 3 through 12. Okay, so it's groups 3 through 12 on the periodic table. So we're going to use the Stock method. Stock is just the name of the chemist that came up with this method or this convention for naming. When naming, add a Roman numeral to designate the charge of the cation. Okay, so our transition metals, they don't always have the same charge. They're always positively charged because they're metals, but they don't always have the same charge. Some might be +2, +1, +3. And so we need to make sure that we're designating that whenever we write it, but this is only for transition metals. Only for transition metals. Okay? If the cation has a +2 charge, for example, then the cation is followed by 2 in Roman numerals. Okay? So here's an example right here. And Fe is iron. Okay? Sometimes iron is going to have a 2+ charge. Sometimes it's going to have a +3 charge. Okay? We're going to talk about this in future videos. I'm just going to let you know it has a +2 charge. And we'll talk about why in future videos. But we'll say that this species has a +2 charge. And then I name my anion just like I did in my previous example. So it's iron 2 chloride. Got it? Alright. Naming with polyatomic ions. So remember, polyatomic ions have more than one atom in the ion. So just like I did before, I'm going to take the name of my cation, and to it, I'm just going to add the name of the anion. I'm going to add the name of the polyatomic ion. I don't necessarily have to worry about adding IDE unless that's already just a part of the polyatomic ion's name. Okay, so here I have an example. I have sodium. Okay, so Na, remember Na was sodium. And I'm going to look at my list of polyatomic ions and I'm going to find Cn. Okay, those are my initials. Wonderful. So Cn is cyanide. So I'm just going to write cyanide. So sodium cyanide. Okay, Sr, I'm going to find it on my periodic table. It is strontium. Okay, I'm going to find OH on my periodic table. I'm going to call that hydroxide. One thing to notice here is that I have this in parentheses. Okay, I have it in parentheses because I have 2 of them. Okay, so I have two of them in my formula unit here, so I want to make sure to designate it with parentheses. I could put parentheses up here on cyanide, but since there's only one of them, it's really not necessary. Okay, this last example here, that's calcium, which I'd find on my periodic table. Then I look at my polyatomic ion list, and I find that that is phosphate, that PO4 is phosphate. Okay, and because there's more than one of them, I'm going to put my polyatomic ion in parentheses. That's why you see it that way. Okay, so that's the end of this video. The next video is going to be writing chemical formulas for ionic compounds. So basically, you're going to be doing it in reverse. I would give you the name sodium cyanide, and you would write NaCN. Right? Bye, guys.